Okay, so the draw cycle. Um, so when draw scene is called, it calls draw on the game engine, which then calls draw on the scene, which calls draw on the drawable objects. Um, so inside of axes, for example, so right here it has graphic object render and then passes the camera. This, the way I have it set up, this doesn't actually render the object right then and there. What happens is render is called, and instead of rendering the object, it creates a draw command, passes in its shader, the graphic object, some other additional information that I'll get to later, and it creates a command. And then this, and okay, so draw command, just to be clear, is a singleton which stores and manages the draw commands. So it has the command pool and it keeps track of the active commands. Okay, so it's inside of here. Yes. Okay. Yeah. Okay. So to draw commands, what they do is they store a pointer to the shader, the graphic object, the camera, the world, and the color. And then when these commands are eventually processed, that's when it actually renders the object to the scene. So it calls pgraph render, and then this actually, come on, calls this render, and then this actually renders the object. So yeah. So let me back up. Come on. Okay. So this is the command. This is the factory. When add command is called, it creates a command. It then passes this command to its corresponding shader. So in order to do that, I have, well, I pre-process the shaders and store them inside of a singleton on the graphic side. So that's what this is right here, graphic shader manager. So this stores the list of all the shaders. This accesses this then stores itself inside of the a shader with the corresponding shader pointer. So let me actually open this up. So yeah. So the string and a pointer to the shader. When I create the object, I create the shaders and then store them inside of the the manager. And then yeah. And then when execute, where is that? When execute is called on the shader manager, what that'll do is it will iterate through the list of execute the list of shaders, and then it will process all of the commands assigned to each of the shaders. Shader. So the main reason for one of the main reasons for doing this is because prior to actually rendering a specific object, its shader has to be set to context right here. So what I could have done instead is if I just kept it as plain as possible, I could, when an object calls render, instead of creating command to later be processed to actually render it, I could just render the object right then and there. I just take its shader, set it to context, do whatever else, then call it. But then I have to do that for every object, and I figured having to make that call would end up being costly. So I figured this would make it a little bit lighter, and it would also give me, at least inside the graphics side, control over the render order of the objects. For example, I want to have sprite objects. For the sprite shader, it's important that it gets rendered last. So in doing it like this, I have control over the order, and it saves me a call or two. So yeah, render. So yeah, it calls execute, which renders it, and then it recycles the command. Okay. What else? Oh, so as I mentioned previously, I'm storing the world, the color, and the camera. So honestly, I just need to store the world and the color for what I'm doing, but anyways. So the reason why I'm storing this is because, say for instance, I have one graphics object. For example, let's do lives. Okay, so this is a graphics object. It has a graphics object. However, inside of its draw, I render it multiple times. And each time I call render, prior to calling render, I update its position. So I needed a way to store the position for each of the calls, calls to the graphics object. So to do that, I had to store the world inside of the command that I put the graphics object inside of, so that when I actually render the object, where is it? Here. Yeah, so when I actually render the object, I have its world at its position when it was called. So I can take one graphics object and render it in multiple different places. And then likewise, if I have a graphics object and I want to render it multiple times but change the color of it each time, I can do that because I'm storing a vector corresponding to its color. So yeah, it's useful, and it was necessary in order to do something like this inside of lives. I think it was also really important for my particle manager, since I just have the one object which I'm creating multiple times. And yeah. So yeah, that's pretty much the draw cycle. Yeah. Okay, I guess I can talk about additional sprites, additional stuff with the additional systems that I need to create. So as I mentioned, most of this project was creating wrappers for the game engine. So I had to create a wrapper for the inputtables. So I had to create my own get key state with corresponding macros for the keys, um, which followed the Azul format. Um, yeah. Along with that, I had to. Well, I didn't really have to set up anything for time processing. For the most part, that was already set in place. Um, where's that? I guess it's in here. Yeah. So yeah, thankfully the game timer already existed inside of the DX application, so I could just get the time from this object and use that for my alarmables and my time manager. Um, what else? Lights. Um, so the one thing I didn't really touch that I was, at least at the beginning, I was hoping to get around to was improving the light system. What I wanted to do was be able to create multiple lights, um, that not like a fixed number of lights, but like create as many point lights as I wanted, or spotlights, or etc. So I didn't get around to that, but I did move out the um, a lot of the stuff to create the actual lights, um, so that inside of so that where is it? Here. Yes. Okay. Yeah. So that I could essentially create a light, and then instead of having to recreate the light for each object, I could just take this direction light and throw it into the shader like that, and I just thought it was a lot easier. Um, but yeah, no lighting system or any of that, unfortunately. Um, so oh, I did get sprites working. So I have a sprite shader. It's really similar to the texture shader. Only difference is how I set up the world. I believe that's the only difference. Where is it? So camera is set. Yeah. No. Oh. Oh no, because this is the shader, not the actual graphics object. Okay. So yeah, the actual graphics object. I just processed the world a little bit differently to take into account the image width and height. Um, and yeah. Um, what else? Cameras. For the sprite stuff, I also had to create an orthographic camera. Um, well, I didn't really have to create one. All I did was I created a orthographic projection matrix. Um, yeah. So assuming that the user passes in the proper variables in order to set up the orthographic camera, I could then use those to create the orthographic NDC. And then I could just pass, once I have that, I can just pass that to the shader, and it should handle it properly. But yeah, the set orient and position, this is the same for both perspective and orthographic, so I didn't have to make one specifically for the orthographic camera. But yeah. Um, what else? I think that's it. Yeah. Yeah.